Good morning students. Today we are going to start practice set 3.2. In practice set 3.2 we are just start the problem number 1. So which is that problem number 1? Two circle having radius 3.5 centimeter and 4.8 centimeter touch each other internally. So they are having the two circles, and that two circle, one radius is at 3.5 centimeter and another radius is 4.8 centimeter. So that two circles, they are touch internally. So the one radius is 3.5, another is 4.8. Find the distance between their centers. So remember students, when the circle touch internally to each other, then there is the subtraction of radius, means which is the bigger radius, that bigger radius subtracted smaller radius. So here is, we can see they are internally touched. So the radius of the first circle is R1 and radius of the second circle is R2. So R1 is equal to 3.5 centimeter because it is radius of the first circle. So here is I write R1 is equal to 3.5 centimeter. It is radius of the first circle, and radius of the second circle R2 is equal to 4.8 centimeter. That is given. Okay. So radius of the second circle R2 is equal to 4.8 centimeter. That is given. So that two circles are touched internally. So here is I mentioned that the two circles are touched internally. So they are touched internally. So the distance between their center can be find out with subtraction of radius. So there is the distance between the center of circle touching internally is equal to difference in their radius. So if you want to find a difference in the radius, so what can you do? Which is the bigger radius R2, that is the 4.8 centimeter, which is the smaller radius R1, that is the 3.5 centimeter. So the distance D is equal to R2 minus R1. So here is that written, distance between their center is R2 minus R1. So here is the right R2 minus R1. So R2 is 4.8 centimeter. So here is I write R2 4.8 centimeter minus R1 is 3.5 centimeter. So here is I write 3.5 centimeter. So 4.8 minus 3.5. So subtract this, 8 minus 5. What is remain 3? 4 minus 3. What is remain 1? So we are getting that answer is 1.3. Are you understand my student what I say here? See, the R2 is the radius, that is the 4.8 centimeter, and R1 is the radius, that is the 3.5 centimeter. So the circle are touched internally. They are not touched externally. They are touched internally. So when the circle are touched internally, then the common difference are subtraction of radius. So when you are subtract the radius, which is the bigger radius R2, that is the 4.8 centimeter. So I write R2 minus smaller radius R1. So R1 is 3.5 centimeter. So R2 minus R1. So R2, what is that R2? 4.8 centimeter minus R1 3.5 centimeter. Such a way. So 8 minus 5, there is remain 3. 4 minus 3, there is remain 1. So 1.3 centimeter is the distance between the two center. So that answer is written here. Distance between the center is 1.3 centimeter. Are you understand it? Is that clear? Remember that student, here is the circle touch internally. When the circle touch internally and you want to find out distance between their center, then you are subtract the radius. When you subtract the radius, circle touch internally, then you subtract the radius. Is that clear? Yeah. Then problem number 2, which is that two circle of radius 5.5 centimeter and 4.2 centimeter, means they are having the two circle. That radius of the first circle is 5.5 centimeter and radius of the second circle is 4.2 centimeter. Touch each other externally. They are touched externally. Such a way, externally. They touch externally. Find the distance between their center. So when the circle touch externally, then we can do addition of radius. So if you want to find out distance between center, then we can do addition of radius. So let the radius of the two circle can be considered. R1 is the radius, that is the 5 point radius of the two circle be R1 and R2. So R1 is the radius of the first circle, that is the 5.5 centimeter, and R2 is the radius of the second circle, that is the 4.2 centimeter. So you want to find out distance. So D is equal to, so R1 5.5 centimeter, R2 4.2 centimeter. So D is equal to, the two circles are touching each other externally. So D is equal to R1 plus R2, because the circle are touched externally. Circle are not touched internally. When the circle are touched internally, then you are subtract the radius. Remember my students, when they are said internally, then you subtract. But when they are said externally, then you addition of the radius. So here is, by theorem of the touching externally, so the all the 3 points are collinear and distance between them is sum of the radius. Okay, so externally, so we can do the addition. Distance between their center is equal to R1 plus R2. So R1 is 5.5 centimeter, R2 is 4.2 centimeter. 5 plus 2 7, 5 plus 2 7, 5 plus 4 9, 9.7 centimeter. So that is the distance between the two center where the circle are touched externally. So my students, remember that when circle touch externally, then you are subtract the radius, and when the circle are touched internally, when the circle are touched externally, we can do addition of the radius externally. When circle touch externally, see this is the externally. So when the circle touch externally, then you are addition of radius, and when circle touch internally, then subtraction of radius. So here is externally, so addition of radius R1 plus R2. So 5.5 plus 4.2, 5 plus 2 7, 5 plus 4 9. So 9.7 centimeter is the distance between the two center. So distance between the two center is 9.7 centimeter. Are you understand my students? Anyone having doubts? If you have doubt, you can ask me. Then problem number 3. If radius of two circle are 4 centimeter and 2.8 centimeter. So there are the two circle. So first circle radius is 4 centimeter and second circle radius is 2.8 centimeter. Draw figure of this circle touching each other externally and internally. So here is circle touch other externally. So we can draw such a way externally. See, this is the bigger circle. That circle radius is 4 centimeter. So this is the OA. See, O is the center of the circle. So from O to A, this is the 4 centimeter radius, and we can draw this circle. Then this is the P center circle. So that P center circle radius is 2.8 centimeter, and we can draw the circle. So when we draw these two circles, that two circles are touch each other externally, so we can draw such a way. So if you want to find out distance between the two center, then you can find out OA plus AP. So 4 plus 2.8, 6.8. But they are not asked distance. They are only show, you can show the diagram. So remember, this is externally touch. See, this is the external points. So it is externally touch. Then internally, circle touch internally. So this is the bigger circle, that is the 4 centimeter. This is the bigger circle, that is the 4 centimeter, and this is the smaller circle, that is the 2.8 centimeter. So the O center circle and P center circle, they are touch each other internally. See, in this point, A point. So they are touch internally, not externally. So internally, so diagram is such a way, and when they are touched internally, then subtract the radius 4 minus 2.8. Such a way you are subtract. So this diagram is internally. Anyone doubts? See, this is touch internally. So diagram is such a way. Then problem number 3. In the figure, fourth problem. In the figure, the circle with center P and Q touch each other at R. A line passing through R meet the circle at A and B. So see, this is the P center circle. Okay, this is the P center circle and this is the Q center circle. So they are having the two center circle. One is the P center circle and another is the Q center circle. So that circles are touch each other in external point R. Okay, that touch each other in external points R. A line pass though R, mid pass though RC. They are touch A point of the circle and they are touch B point of the circle, A and B respectively. So what you want to prove? You want to prove that AP is parallel to BQ. So how can you prove? You must be show that this alternate angle and this alternate angle congruent, then AP and QB is parallel. Another triangle APR, similar triangle RQB, you want to prove that. Then RQB is equal to 35, sorry, you want to find out measure angle of RQB, PARC. This is the A angle, 35 degree. So you want to find out RQB. So we are just start to prove that. So first, P dash R dash Q. So they are the two circles, they are touch each other in externally in the point R. So circle are touch externally, so that can be shown such a way. So in triangle PRC, this is the PAR. So in this triangle PR, P is the center of the circle. Okay, so P is the center of the circle. So PA is the radius and PR is the radius. So radius of the same circle are congruent. So PA congruent PR. So here is we write that segment PA congruent segment PR, radius of the same circle. You can see here, this is the P is the center of the circle. So PA is the radius and PR is the radius. So PA congruent PR, radius of the same circle. So these radius are congruent, so opposite angles are congruent. PA's opposite angle R and PR opposite angle A. So angle PAR congruent angle PRA. Are you understand what I say me? See my students, this is the PA is congruent with PR. Why they are congruent? Because radius of the same circle are congruent, so they are congruent. So all of you know very well, you are already learned in 9th standard, when two segments are congruent, opposite angles are congruent. So here is the PA is congruent with PR. So PA's opposite angle R is congruent with PR opposite side A. So angle R and angle A are congruent. So we can write such a way, PAR congruent with PRA. Isosceles triangle theorem. So see here, angle PAR means that such a way, PA is opposite which PR. Okay, so PR is opposite PR. So this R angle is congruent with PR opposite which angle A. So here is we write angle PAR congruent with angle PRA. Such a way they are right, angle PAR congruent with PRA, isosceles triangle theorem. Are you understand? See my student, these two segments are congruent, so their opposite and side opposite angles are congruent. So PA's opposite angle R and PR opposite angle A. So angle PAR congruent with angle PRA, isosceles triangle theorem. Then another. So there is another triangle. See in this circle, QRB triangle. So in this QRB triangle, Q is the center of the circle. Okay, so this Q is the center of the circle and this QR is the radius of the circle and this QB is also radius of the circle. So this QR and QB is the radius of the same circle. So radius of the same circle are congruent. So QR congruent QB, because radius of the same circle are congruent. So here is written segment QR congruent with segment QB. So at the QR opposite angle B, that is congruent with QB's opposite angle R. So angle R and angle B are congruent. So we can such a way write here that two sides are congruent, so their opposite angles are congruent. By isosceles triangle theorem, we can be write that such a way. So here is angle CQ, R and B. So this R angle is congruent with B angle. So the name of this angle, angle QRB, congruent with angle QBR. So here is written that my student, QRB congruent with QBR. It is very simple. Remember my student, when segment congruent, then segment opposite angles are congruent. Is that clear? So angle QRB is congruent with angle QBR. Reason is isosceles triangle theorem. So there is the another possibility is that the angle PRAC, this angle R angle is congruent with angle QRB because it is vertically opposite angle. So vertically opposite angles are congruent. Remember, when shape is X shape, then it is vertically opposite angle. When shape is Z shape, then it is alternate angle. When the shape is F shape, then it is corresponding angle. Observe the shape. When shape is such a way X shape, then they are vertically opposite angle. So vertically opposite angle PRA congruent with vertically opposite angle QRB. So when the shape is X shape, then they are vertically opposite angle. When the shape is Z shape, then they are the alternate angle. When the shape is F shape, then they are the corresponding angles. So such a way, angle PRA and congruent with angle QRB vertically opposite angles. So from 1 to 3, here is angle PR congruent angle QBR. So angle PAB congruent angle QBA. So we are giving the number here 1 to 3. You are observe that PR congruent with QBR. Then this PAB congruent with QBA. So A dash R dash B. So AP is parallel with BQ. Alternate angle test for parallel line in triangle APR and triangle RQB. So that you want to prove, that you want to show similar. So first thing, angle PAR congruent with angle QRB. First one and third we are same. Angle PRA congruent angle QBR, second and third. So triangle APR similar triangle RQB by a test of similarity. So that we are already proved that this angle PAR congruent with QRB 1 and 3 from. Then angle PRA congruent angle QBR 2 and 3. So these triangles are similar by AA test. From 1 to 3 we get angle PRC, angle PR congruent with QRB. Here is we are written, and it may be shown in the last scale angle PR congruent angle QBR. Then angle PABC, angle PAB congruent angle QBA, A dash R dash B. So they are congruent. So these two angles are congruent. So segment AP parallel to segment BQ, alternate angle test of parallel line. Then in triangle APR and triangle RQB. Okay. So angle PRC, here is we prove that angle PR. So right here angle PR congruent angle QRB. Okay, congruent angle QRB 1 and third. Then angle PRA congruent angle QBR. See this QBR. So 2 and third. So these two angles are congruent. So the triangle APR is similar triangle with RQB by a test of similarity. A test of similarity. Then angle PAR is equal to 35 degree. Angle PAR is equal to 35 degree. Given. So here is PAR is equal to 35 degree, that is given. So what you want to say here? So you want to prove that from 1 to 3 that is given to you. So angle PAR means PAR. So this A angle is congruent with R. So if it is 35 degree, then it is also 35 degree. So angle PRA is 35 degree. Then this vertically opposite angle, this R. So angle QBR is equal to 35 degree. Okay. So in triangle QRB, we can write here QRB, this triangle, QRB triangle. In this triangle QRB, angle QRB R angle plus angle QBR B angle plus angle RQB is equal to 180 degree. Sum of angle of triangle. So 35 degree plus 35 degree plus angle RQB is equal to 180 degree. 35 plus 35 70 degree. So here is 70 degree plus angle RQB is equal to 180. Angle RQB remain as it is. 180 also remain as it is. Plus 70 go across, minus 70. So angle RQB is equal to 180 minus 70. So what is you are get 110 degree. So angle RQB is equal to 10 degree. Angle RQB is equal to 110 degree. Very simple. See, this angle 35 degree, this angle 35 degree, because two sides are congruent, opposite angles are congruent. Then this is vertically opposite angle, so this R is 35 degree and B is 35 degree. So 35 degree, 70 degree. Okay, plus angle RQB, that is not given. So here is the angle RQB is equal to 180 degree. angle RQB is equal to 180 degree minus 70 degree. So 180 degree minus 70 degree, what is remain? 110 degree. Triangle QRB, see this is the triangle QRB. So angle R 35 degree, angle B 35 degree. So we can write angle QRB plus angle QBR is equal to 35 degree plus angle RQB is equal to 180 degree. Sum of angle of triangle. So 35 degree plus 35 degree, how many? 70 degree. So that 70 degree is right here. Plus angle RQB is equal to 180 degree. 70 degree positive, go across negative. 180 degree minus 70 degree. What you get? 110 degree. So angle RQB is equal to 110 degree. So I write here angle RQB 110 degree. So this problem number 5 is given to you. That is, the problem number 5 is a combination of 1 to 4 problems. Okay, so please try to solve this problem. If you have solved this problem, then I think that you are understand what I taught you. Okay, and this problem is very important, so you must be solve this problem. If you are not able to solve, try first, and if you are not able to solve, then say to me. I will again explain you this problem. So stay home, stay safe, and study hard.